Hello, welcome to the Building Energy series. I'm your host, Jerrod Downey. Rory is actually supposed to be hosting these episodes on building energy, but he is off traveling. So I am back filling in my old role as host. And today, which gives me the opportunity to do a third episode with Anton Paar Canada. And they have done one on the building energy series before. We're going to do another one here with Atri Maharaj. Atri and I did a Mining Now episode, so we're getting to really peel back the layers here with Anton Paar Canada. He is the sales manager for characterization at Anton Paar Canada. Atri, welcome to the show. Good to
Thank,
have you on.
thank you so much for having me on again. I'd like to say one of the best bits of feedback I got, other than how engaging our conversation was the last time, was I have a good buddy who lives out here in Burnaby. He paid me a compliment. He said my speaking style, my mannerisms reminded him so much of Neil deGrasse Tyson.
Oh,
And for me being a physicist, I said to be compared to one of the most
yeah.
well-known physicists in the modern world in social media, kind of really touched my heart, so to speak.
Well, I watched a long interview with him, and he was talking about how he learned to communicate these really complicated ideas. And the process he went through it's quite complicated because you really are capable of speaking a completely different language.
Yes.
And it truly is like a different language. And
Yeah.
so that ability to then transfer that so that people can understand it, and especially here on like a show where
Mhm.
sort of that goal is to then reach out and someone's like, oh yeah, we do need that, and like try to
Yeah.
explain that now to someone else. It's quite the challenge. But I'm
It
glad you got the compliment.
I really appreciate the compliment, and I don't know if you meant it as a joke or not, but he sent me the YouTube video of Neil deGrasse Tyson when he was on Hot Wings, so I watched
I
this
never
with.
thought of that.
It's pretty good actually, so I'll give you that to enjoy later. So I showed it to my wife, and she's like, "He's right."
Well, now that you're saying it, that's all that's in my head.
Yeah.
Um, no, it was a good and it's hard to have technical discussions at the live event like at PDAC because you got a lot of movement. This is a little more of a controlled environment, so
Yeah.
it's going to be an interesting uh, dialogue today because we have a little more time to actually dive in. And I wanted to start at the high level of
Hmm.
the goal of coming on this show, and sometimes I don't ask that, but the reason
Hmm.
I am is because some of these topics are quite technical
Hmm.
and complicated for
Hmm.
people. So I think if the audience has an understanding of what we're trying to accomplish here,
Hmm.
then they can kind of tag along for some of the more technical parts.
One of the reasons that Anton Par has been so successful over our 101-year uh, existence is probably the best word that
Mm,
I can use, is our connection to the research community, to the innovators, the people who are pushing boundaries in industry. Yes, we manufacture instruments. Yes, we sell instruments to the industry. But a large part to what we do and what makes us successful is that connection and the education side of
hmm
things. So as industry continues to grow, as technologies continue to evolve across the world and across our daily lives, so too do our instruments, the techniques, the science that goes in behind it. So, as part of our conversation today, what we'll be talking about, of course, are the instruments that we manufacture that will benefit the battery industry, but also to build on why the instruments are pertinent to some of
hmm
the challenges that we face in the battery industry these days.
When you need support and results with your project's safety, call Kaizen Safety Group Inc. Breathing air, gas detection, technical rescue, and safety advisor services, all driven by their proprietary industry leading safety culture and leadership programs, are the positive safety difference you've been looking for. Kaizen Safety Group Inc. committed to the continuous improvement of your workers' safety and well being. To learn more, visit kaizensafety.ca. You keep the world in motion and you need travel support that doesn't stall your momentum. With Corporate Traveler, their seamless blend of innovative tech and tenured expertise means they know what it takes to navigate the tricky logistics behind oil and energy industry travel. Save time and money and keep your team safe. Have an emergency? They've got you 24/7 anywhere on any device. Booking travel has never been easier. Get it done with Corporate Traveler. Visit corptraveler.com today. Cut's fourth commitment to innovating technologies for the power industry has been the biggest driver in developing their innovative and unique offerings. Their patented easy change brush holder design, shaft grounding, and monitoring systems have been installed across the globe. Ever evolving, they recently expanded their offerings through the acquisitions of Insight CM, an online asset monitoring platform, and WSC Consulting Services. They are continuously supporting the power industry through the power of innovation. Visit cutsforth.com to learn more about their products and services. That's cutsforth.com, and you can also watch out for Cutsforth's upcoming 3-part series.
How much has the industry just ramped up? And I know that's sort of like an obvious question that it
Hmm.
has ramped up.
Hmm.
But how much from an Anton Par perspective
Hmm.
in the last, I don't know, let's say 15 years, how much has it just went way beyond scale of even expectations, I would say.
The example that I'll probably use is when I was in university back in the early part of the century. Yeah, I love saying that. Date myself a little bit there. Solid state batteries were not as prevalent as they are today. And if you knew something about a solid state battery and you could speak intelligently on it, you were sort of crowned as an expert.
Mm,
But now they've become so ubiquitous in many things you're doing, from your cell phones to laptops, um, somewhat in the IoT industry as well. But again, ubiquitous and prevalent, probably the two words that would best describe how much we see solid state batteries now. It's a technology evolving, batteries evolving to match the needs of society and growing as a whole. So from just being able to hear how commonplace they've become from
hmm.
a thought that existed 15, 20 years ago is quite remarkable behind that. So not just that, but people had thought about, your standard batteries. I believe the proper term is like a primary battery, which means the non-chargeable battery.
Hmm.
And now a lot of the batteries we're working with, because you have your phone, IoT, etc., as we mentioned before, now we're seeing the secondary batteries, which are rechargeable batteries.
Hmm.
And given the need for power in all these myriad of devices, this is where the battery industry has grown to meet the need. So devices where you didn't think a battery would have been necessary to for performance, this is where it's grown there, and it will continue to grow because as we move towards more of the wireless, I saw somebody walking down the street the other day, and they had wired headphones in, and
Hmm.
kind of shocked me. I'm like, how do they not have AirPods or like a
Hmm.
Bose headset, the wireless or something? And then you realize that's where we are now. We're expecting everything to be wireless,
Hmm.
Bluetooth, battery related, the mobility, the accessibility behind it. And it's when you take a step back and then you realize how much we need batteries.
Yeah, and how quickly that's what I was alluding to, is just
Hmm.
how quickly like I think on the roads, I think it's only, this might be a BC stat, but
Mm,
it's only like 1% of vehicles are electric.
yeah,
But if you think about how many vehicles there are,
that's quite a lot of
that's a
vehicles
lot
on
of
the road.
electric vehicles
Yeah,
that just didn't exist.
yep,
That just didn't exist 10 years ago. It wasn't even close to 1%.
yep,
And now I mean, everybody's got an electric car. There's electric trucks. I
yep.
mean, they're coming in waves. Where does In that sort of vein,
Hmm.
where does Anton Par come in that process? Like, how far back in the manufacturing of these
Hmm.
batteries does Anton Par step in? Pretty right from the beginning, pretty much,
Hmm.
right?
Pretty much from the beginning. When we're looking at the design formulation of different components, a lot of our instruments and techniques fit in very well in the early stages behind that, and it goes all the way down the supply chain as well. So when you're thinking about a battery is fairly simple: anode, cathode, separator membrane, electrolyte. Whether you're talking about a lithium ion battery or the new upcoming lithium sulfur batteries, which we'll see more of for transportation because they can hold a higher um, energy density. So a much longer lifetime, of many more cycles, etc. All the way across the hydrogen fuel cell. It's the same basic construction. So your electrodes, the separator membrane, and your electrolyte. What happens in between, the chemistry is a little bit different there between. But that's what we understand in the early stages of the battery. But when you think about how you're applying them later on, you have to think about heat dissipation is something that we hear a lot about. You always hear about the battery overheating. Can you use it in this environment,
Mhm.
etc. So understanding how you construct the battery to dissipate that heat so that safety can be adhered to. When you think about EV, um, the amount of power, the amount of torque that you have driven to your wheels these days is a lot more compared to your standard gasoline vehicle. So when you think about you've all seen wheel spin on race cars, etc.
Yeah.
That's kind of what's happening now with EVs we have on the road, and not everybody can buy a new set of four tires. So this is not a problem, but the evolution is probably a word I'm going to overuse in our talk today. But
Sorry, how does the connection of the
mhm,
I understand the electricity, the power that is
mhm,
instantly to the tires.
yes,
So, but does that have to do with the composition of the batteries themselves?
yes, and yes and no. Some with the composition of the battery in terms of what the power is available, but it also depends on the technology put into the car, how they deliver from the battery to the drivetrain.
Right. Okay, so these the car manufacturers now
Hmm.
have they're all offering an electric vehicle, a hybrid
Hmm.
vehicle. So there's all these different batteries in all these vehicles. What separates one out from the other?
Hmm.
Is there an actual difference in battery? Is it just the size of them, or are these actual different batteries?
Hmm. Now, I mean, with the drive to produce more electric vehicles these days, I think some countries are at 2035, some are 2045 to stop selling gasoline vehicles. So you have various needs, as you're saying, for hybrid vehicles, full EV. So it feeds into each other when you talk about different types of batteries, different
Mm,
qualities of batteries. Something I would also say is the feed time as well. One of my colleagues drives a Prius, and we were talking about like you charge the battery, you'll get 40
I
kilometers
used to
out
have
of
one of
it.
those. I love that little car. I really love that little car. Yeah.
Okay.
I feel like you're gonna knock it, but I loved it.
I've never driven one. I've never been drawn to one.
Yeah.
I was going to say if I was going to get a battery vehicle right now, I would probably get the Kia Niro. Now,
I don't know.
that's a personal preference
Oh,
more
okay.
than anything there. But if you think about it, if you have a battery that's going to get you 40 kilometers and you just run it on one charge, you expect the delivery of energy to be different compared to something that can go a couple hundred
Right.
kilometers. But generally, one thing that is a bit more distinct, let's say, between batteries in terms of quality is the slurry and the slurry preparation that goes into this. So we have your electrodes in the battery that we talked about before. So these slurries are prepared and they're coated onto the electrodes. And there are three basic components that come into this: carbon black, graphite, and some type of a polymer. And what they do is the carbon black is there for the conductivity, which is necessary for
Mhm.
anything electrical. You have the graphite, which is the active component, and then you have the polymer, which is the binder that keeps everything together. It's in a very, very small percentage, like less than 2% into your slurry. But the quality of the carbon black, where does the carbon black come from? The graphite, how was it refined? What was the source
Mm.
material? And the type of polymer that you're using all feed into this. So depending on the ratios in which they're mixed, the source material, the raw material, how that's qualified incoming, they all affect this full slurry that then affects the electrode, which then affects the end performance of the battery as a whole.
So does it come down to a high end, like, is it tiered? Like,
Hmm.
does everybody know who's manufacturing these?
Hmm.
If we use this material
Hmm.
in this mix,
Hmm.
we're gonna get this level, but it costs X amount more, but we
Yep.
can get there. And then as you tier down into, let's call it different levels of vehicles or whatever the application is,
Sure.
they pare it down based on cost or application. Like you're saying, like a Prius Prime, you don't need it to go 200 kilometers.
Yes. Yes.
That's
And
my very simplified understanding of what you just said.
it fits, and it actually opens up a larger conversation and a larger bit of analysis behind it, because one of the things that the battery industry is looking to do is to standardize so that you don't have a good battery that ends up in a Prius Prime versus the other. You want the
Mm.
same
You're
customer
not we are
satisfaction.
not brought to you by Toyota, by the way, just in case anybody's wondering. But they are welcome to sponsor us
At any given
at
time.
any given time. No, sorry.
um but it's a standardization behind it. So you're always going to end up with certain types of instruments where you have the more premium, so to
Mm,
speak, electronics or something else like that. And you'll get the same thing in the batteries as well. I mean, like a kid's toy, you don't need the highest performing battery
yeah.
for something a 3-year-old is going to throw against the wall and break later on. But as I was alluding to, the conversation that opens up is the standardization. Where do we take the research to optimize the production
Mm,
and manufacture of these batteries? So to come back to the three main components. So you look at the carbon black, you look at the graphite, you look at the polymer. The polymer is, even though it's in such a low percentage, like 2% weight by volume in the slurry, it is crucial to how this slurry is going to move throughout the manufacturing process. In the coating process, you're typically working with either a slot die coating process or a blade coating process. And the slurry is introduced differently onto the substrate, which is like a metal foil, uh, copper or something else, depending on whether you're working with an anode or a cathode. And you have to think about the spreadability behind it and how it moves, because the recovery process, as you move it through a pipe, you're going to have natural contraction and expansion, but it doesn't recover very quickly. Last time I gave you the rheology example of the toothpaste. That's a perfect example of you apply a stress, it
hmm.
comes out, but it recovers very well onto the toothbrush and also back into the tube.
Right.
So that's what I mean by a fast recovery process. But when it comes to the slurry, you don't. It's a much longer time scale for that recovery, and it affects. You could have the best formulation of the slurry prepared there, but when you're actually putting it onto the coating, is it getting there the way we
Mm.
wanted it to? And that then has a trickle down effect of, is this electrode going to short out, for example? A very, very simple example, but is there potential for it to short out to
So
degrade?
short out is sort of worst case scenario, and then what's
Hmm.
in between short out and best case scenario? Is there a whole bunch of little? Is it one or the other, or can it perform somewhat well?
It can perform somewhat well. You can have fewer cycles behind it. You can have degradation, much faster degradation over time. You could also have poor delivery. Um, I bought a rechargeable battery for my Xbox controller and worked well the first time.
Hmm.
They were promising it to perform as well as the standard Xbox battery, but I'm sitting there playing GoldenEye and start shaking it. What the heck's going on here? And this is one of the things, like, somehow you shake it, the electrolyte goes the other way. Oh, yep, here we go, we're
Oh, so
back to life.
that's actually a real thing. No.
Personal experience.
Oh,
Personal
not
experience.
scientific.
Not scientific. This
Okay.
this will be in an
You're gonna see people they're shaking their
right.
cars.
Could you imagine? I mean, that's how we used to do jump starts back in the day, right?
Yeah.
I remember back in the early '80s, like I jump started my uncle's car. Like he's like, "Get out and push,"
Yeah.
right? Like, you're bigger than me. Anyway,
Yeah.
another story for another time. But many different factors are impacted by this. You can see dendrites getting built up on the separator membrane, leading out to poor energy that density, poor diffusion. And it degrades. So it all everything is, because it's such a compact cell. That's the way most people think about batteries. Are the term that's
Like
more
you're saying,
scientifically
like,
used.
but it's actually quite like
Yeah.
when we're working with like the physical size
Yep.
of what you're working within is a very small thing,
Yep.
right? These cells, like how big are they
Well,
roughly?
think about your phone. Um, about up until about 10 years ago, Samsung used to sell batteries that you could swap out in your phone.
Right?
You had the
Yeah.
spare battery, right?
Yeah.
This is something that we call a pouch cell. That rectangular
Yeah.
type of a battery. That's a small battery. Then you have coin cells, which think about your watch, right?
Yeah.
That little tiny round thing, that's a coin cell. And then we know the standard cylindrical type of battery. So it brands across, not brands, excuse me, it ranges across various geometries and applications behind it. So,
So where I want to pivot to now
hmm
with this context is what is Anton Paar then
hmm
actually delivering to do all this testing?
sure.
I'm probably waving my hands into your frame, so my apologies to the audience. But what are you what machines,
hmm
what services,
hmm
what actually gets packaged in? Let's go day one. It's a battery manufacturer. They're
hmm
making batteries. We'll
hmm
keep on the car
hmm
example. They're coming to you and say, "We're doing this. We need your services."
hmm
What's the list that you're providing them?
So it starts with the raw materials. I think I used this stat the last time we spoke as well, but it still holds true. Nothing changed since
There's
then.
always a new audience every time too, as well, so we're good.
About 95% of raw materials across industry are in a powdered form. So again, we talked about the carbon black, the graphite, the polymers, etc. So you need to understand your raw materials before you get to the slurry. The slurry is going to be step one
Yeah.
before
So
we get
this is material they're purchasing or are thinking about purchasing.
purchasing or thinking about purchasing.
Okay.
On the manufacturing side, they always have to supply a COA, certificate of analysis, but stuff happens during transport. It's just the nature of the world. You want to make sure that you qualify your incoming materials. So now you have a
Right.
baseline, you know where you're starting. That's where quality and consistency starts, is incoming qualifying your incoming materials.
So they're getting sold. They're getting sold a bill of goods. They're wanting you to verify sometimes secondary verification, saying, "Did we actually get what we paid for here?"
And that's what our instruments provide to
Mm.
them. So um, one of those instruments is something called the Nova BET. So BET is a very long set of names, three names, but basically it's called a BET surface area test. I won't go into the three names because I will butcher all three of them, and I'd rather
Know
not.
your strengths,
Yeah,
right?
exactly. Play to your strengths.
Yeah.
So most people call it BET or BET analysis. I'm just so used to calling it BET. So you do a surface area analysis, you do a particle size analysis with one of our particle size analyzers. Is actually called the PSA, very cleverly named. So you would look at how it would behave. So particle size and surface area share an inverse relationship. So the smaller your particle size, the larger your surface area. And when we're working with something like a battery material, we want that large surface area so we can deliver more energy. We can have more reactivity and deliver more energy in our battery. So we understand the surface area, we understand the particle size. Does it meet our parameters before we introduce it into the slurry? Then when you get to the slurry, we talked a lot about rheology the last time. Uh, the slurry, when we were talking about the thickeners in the mining industry, we talked about that constant shear rate, where we have another slurry, oddly
Hmm.
enough, coming in. We wanted to maximize the flotation, etc., so that the water could be reused. Now with the slurry, it's because of its constituents, you get to a point where if you shear it too much, if you think about introducing it into the slot die, etc., it reaches a point where it doesn't flow. And this is where we have the poor recovery process. So the rheological,
Like doesn't flow as in like starts to thicken.
yeah, it gets into like a sludge, and then
Uh,
you just can't move it anymore because you.
so is this just so I get a kind of a picture on my
Mhm.
mind? Maybe we can, in post we can bring a picture up for it.
Mhm.
When you're saying a slurry, is this? I mean, I'm thinking in terms of mining world where these giant
Mhm.
slurries. Is this a big thing or is this like a lab size slurry by this time?
In the early stage, it will start with a lab size, but eventually you'll get up. You'll probably be starting on the milliliter scale, but then you're going to be getting up to the big liter scale because you're going to be making a lot of batteries, right? You're going to
Right.
be when you're starting with your electrodes, you're going to have like a long film, a thin film.
Yeah.
It's going to be meters long, so you'll need to be able to coat
Yeah. Right.
across
So
this
like
film.
the size of a room or like the size of a football field? Like what do we? Just scale or the
Mm.
difference depending on the manufacturing facility.
There is a local battery manufacturer here in BC. They're out in Maple Ridge,
Hmm.
and I visited them a couple months ago, and I looked at their calendaring machine. And the calendaring machine will probably fit in our studio, which is probably like a 10-foot wide
Oh,
room.
okay.
And you just have the rollers going back and forth. So you'd probably be producing something on the scale of a football field, but the actual machine fits in like a 10-foot wide room.
I see. Okay. So now we're at that. So now what are you providing in that system?
So for the calendaring side of things,
The what you said about the slurry,
mm,
I took you off on a tangent when you said about this making sure the slurry doesn't
mhm,
essentially get too thick.
right.
Yeah.
So that's where we'd start with the rheological characterization to make sure as we're moving it, because as we know, the rheologists love to say everything flows. So we need to make sure we have the shear rate optimized because we need to work in that very small that large recovery window, excuse me, to optimize our slurry so that it's moving properly to account for all the variations of contraction, expansion in the pipes, etc., making sure it gets there. So it gets to the slot die and it goes through a slot die and then it gets spread out. Or a bigger slot die is a little bit more expensive than a blade coating. So sometimes you have the blade coating, it gets plopped down and you have a heavy edge on the blade and it just gets spread out,
Mm.
right? Anybody who's baked a cake before and put frosting on, This is kind of like the blade, where you're
Right.
looking to get it perfectly smooth, like you see the chefs do on TV, but you always have a mark somewhere. There's a little lip.
I don't even try. But I know the principle.
I watched my wife struggle a couple of weeks ago making my birthday cake, and this is why the analogy is so
Got it.
fresh in my mind.
Got it.
She tried so hard to get it perfectly smooth, but they're
Yeah, yeah. So this is the same. That this blade, and then
exactly
what's the other system?
a slot die.
Slot die. Okay.
So, in a slot die, basically you have a tube up at the top, the slurry goes down, and then the die carries it over like this.
Right.
A little bit more complicated on the engineering side, which is why
Right.
it's a little bit more expensive compared to the blade. But with the blade, if so, the key here now is to get this coating perfectly flat. So you have a homogeneous slurry, and you want to make sure it's well distributed across the substrate. One of our instruments that comes into play here is something called a scratch tester for adhesion testing.
Hmm.
Number one, to make sure the slurry sticks to the surface. And then you do some other types of testing to make sure it's well distributed. So this is our surface type of testing. So in the Anton Paar parlance, we call it MSC, so mechanical surface characterization. So understanding the tribological, I think I'll stay away from more jargon there.
Okay.
I'm very much in my own space there with some of the jargon that I don't want to start losing the audience. I
Yeah.
apologize at the very beginning there.
No.
So understanding number one, primarily how it adheres to the surface, the adhesion type testing to make sure it's stuck there properly, and then also you have a nice level because you don't want bumps and cracking or anything else throughout the surface. So that's where we start with optimizing the slurry, rheological, particle size, etc., making sure you have the right density behind it as well. Then, as it gets to the coating process, this is where the mechanical surface characterization comes into play. Now, after the electrode's done, next step is assembly.
Mm-hmm.
So we get to the assembly, and let's jump way, 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 way ahead. And now you have a fully assembled cell. So a fully assembled cell. Is our slurry going to do the right job?
Mm.
Not something where you can just like poke and prod and say it works well. You actually have to run the battery. So people run these cells in something called a potentiostat. Not something that Anton Paar manufactures, but it's standard to run through various cycles. Like you're running it through as many cycles as possible to make sure you have charge, discharge, and the
Right.
battery's functioning properly. But before you get to that, there is a type of testing called X-ray diffraction. So we manufacture an instrument called the XR Dynamic 500. What you're doing, extremely simple definition. Please don't come for me, fellow physicists and chemists. You're shooting an X-ray at the
Or
battery.
do it. Probably will drive up our views. So yeah.
That's all it is these
Light 'em
days
up.
are views, right? Well, before I come back around to this, I did meet some people from PEI who watched
I
the
know.
last podcast, and I did need to apologize profusely.
I was so happy. I was so happy when you walked into that.
Oh my goodness! So yeah, thank you for your viewership, and I was very happy to engage thereafter. So,
You need to go there now, of course,
right,
too.
yeah, I might have to change my name with this one with the
Yeah.
physicists are going to come.
Yeah,
for me.
yeah.
But anyway, so you shoot an X-ray at the battery, and the idea behind this is to look at the crystal structure. So as the battery is charging, discharging, you'll see changes in the crystal structure, and this type of in situ testing tells you exactly how the battery is performing
Mm-hmm.
in real time, and that's crucial to going back and saying our process is working. Now again we can go back and look at this qualitatively, quantitatively, and say what happened during the production run, what happened during the formulation run, what do we need to fine tune,
Mm.
and that's where we are throughout the process. So starting from the formulation side, manufacturing your slurry, synthesizing your slurry, getting it coated, onto the electrode, and then looking at the final product at the end.
Optisize is a leading edge geophysical acquisition design and software company. Optisize provides innovative seismic survey designs utilizing the latest field technology and optimizing for advanced processing and quantitative interpretation techniques. Optisize's mission is to bring sustainable exploration solutions to energy development with their custom land footprint reduction technology, Ecosize. Ecosize enables operators to focus on reducing their environmental and greenhouse gas footprint while imaging all their subsurface targets and reducing costs. You can visit them at optisize.com to learn more. E3 Lithium is a lithium resource and technology company aiming to power the growing electrical revolution. Based in Alberta, E3 Lithium's combined resources, including the Clearwater project, are being developed on the backbone of the mature and sophisticated oil and gas industry that will allow the company to accelerate its development. Visit them at e3lithium.ca to learn more. With more than 100 boilers in the rental fleet, Nationwide Boiler is more than a world-class rental boiler company. In addition to supplying reliable rental boiler equipment, Nationwide is also a manufacturer's representative and stocking distributor, offering new and refurbished boilers for sale. An expert in the field of ultra-low NOx emissions for boilers and fired equipment, and a design and build UL certified factory for custom control systems. Visit nationwideboiler.com or give them a call today at 1-800-227-1966 to learn more.
You're putting this together for clients
Mhm.
is, I mean, there's other competitors in the space, of
Mhm.
course. Is it are you integrating within other systems, or a lot of the times is it your instruments that you're right from the get-go,
Mhm.
or are they upgrading their systems and
Mhm.
you come in? It's always I always find it interesting at what stage companies get
Mm.
involved in that process. Can you integrate? They go, okay, we need this specific tester now. You go, okay, yeah, we'll
Mhm.
plug that into your existing system. Where does it sort of obviously you always want to be there at the very beginning,
Always.
but I'm sure they're retrofitting plants and there's all sorts of stuff happening within the industry as the battery world just gears up.
Yeah.
So I'm just curious of how you approached that integration.
There are, coming back to our earlier talking point, was how has it grown?
Hmm.
There were a lot of companies who were very small scale. They spent a lot of time invested in R&D, but now, given the need in the market, they're starting to scale up more.
Mm,
And what they found is that they were good at the small scale, but as they're moving into the large scale, there are many things they didn't consider.
mm,
And this is leading to a lot of additional research and product improvement behind this. But I would have to say the battery world is as competitive as it is for us as instrument manufacturers, as competitive as it is for the battery manufacturers themselves. It's quite a collaborative environment.
mm.
To give you an example, there's a company I was working with in Toronto, and they're manufacturing a very different battery. We hear a lot about lithium ion batteries now. They're working with a zinc oxide battery, and kind of similar process. Their slurries, etc. We started talking to them about where they were, how they were trying to scale up, etc. But one of their biggest pains was the separator membrane. So we talked about the electrolytes, the electrodes, excuse me, before. But one of their biggest pains was characterizing the separator membrane, because through the separator membrane, that's where the electrolyte solution goes. So I think about it more as the functional heart of the battery.
Mhm.
Other people would say the electrodes, but it depends on your perspective. So me having worked a lot with membranes, I'm a bit more biased on this side. And so to understand, if you think about it, the separator membrane, it's a porous structure, right?
Right.
And you need to make sure you have the pores fine tuned so you don't have too much flow of the electrolyte
Mhm.
solution or too little flow. Again, this degrades the life of the battery. So for them to scale up, they need to focus on the separator. For others, they need to look at moving the slurry like you're making on a small scale, you're moving to a large scale. What's
Right.
the shear rate behind this? When you talk to people in the early stages who are setting up, like in my hometown of Windsor, Ontario, there are quite a few battery manufacturing plants that are being set up, and they start the question with, what do we need? And they look to the outside, to the scientific community to say what they need.
So who's setting it up? Is it people with a background, or is it an investor saying we're this is a good space to be in? Let's put resources. Like, are they equipped to do it? I'm not trying to like call anybody out or
Sure, sure,
anything,
sure.
but people see an open space and then
Yeah.
they start putting capital towards that.
Yes.
Is this capital coming from within the battery industry, or is it also people from outside the industry going, okay, let's pivot into this one?
It's both.
It's both, yeah.
The example I was using from Windsor is there was a company, they were more focused on polymers, and
Mm,
making things from into plastics based on their polymers, because they were so. Windsor's the perfect example of this. Windsor, the Motor City.
Hmm.
the Canadian Motor City. We're right across the border from Detroit, which is
Yeah.
the Motor
Motor City.
City.
Yeah.
Um, but Windsor's a perfect example because a lot of the industry in Windsor historically has been around the automotive sector.
Right.
But it's not just about the transmission plant. It's not just about the assembly at Stellantis, right? Where they manufacture the minivans, and you drive up and down this Tecumseh Road in Windsor, you'll see a few thousand minivans coming across.
Yeah.
But it's not just about that. You think about the bumpers. You think about your rims. That everything else are supporting industries around there.
Right.
So one of these companies, they were working in injection molding, and you wouldn't expect injection molding to go to batteries, but because it's a supporting industry and it's evolving so much into the EV, this is how they got involved. So they know their expertise in polymers, plastics, and they know the manufacturing side very well. They know the automotive industry as a whole,
Right.
but when it comes to batteries, they know where they want to go, but
Right.
what do we need to be successful?
That must be a major investment and pivot.
Quite a bit.
Yeah.
And this is where you find a lot of consultants in the battery industry are crucial to the success, and especially in Canada, to driving that success forward. You have people who are well versed in batteries and manufacturing as a whole, but more so on the science of this, and they're able to help focus the energy. Like, that was an intended pun, by the way.
Right. Yeah.
Oh.
I'm listening so intently. My wife gets fun. I miss jokes like, and which is the irony is I love comedy,
Yes.
but people like irony and stuff. I'm just like I don't what, and then it lands like 2 minutes later. I'll be like, oh, I see what you're trying to do
Yeah.
there.
Well,
Maybe I just don't like puns.
potentially. We're so used to saying, that I didn't intend that pun, right?
Yeah, yeah,
Like
yeah. No
I
pun
like to
intended.
go the other way.
Yeah,
I
yeah.
like to go the other way around. It's like, yes, I did. That's what I wanted to say.
The these so, and I guess this kind of leads back to that question though,
Hmm.
is when companies are making these pivots, and I think it's a
Hmm.
really important topic
Yep.
because people watching this episode are, of course, trying to figure out where to put capital,
Hmm.
or they've already put capital somewhere.
Hmm.
In that, where you said battery consultants,
Hmm.
where does Anton Paar come in
Hmm.
that consultation process? Or is it a consultant coming to you and saying, hey, they need you need to be part of this plan?
Hmm.
Where are you actually getting into that process? In that specific, that pivot type,
Hmm.
we're pushing into a new industry type thing.
Sure. So there are other manufacturers out there who manufacture things that we don't at Anton Par, and there's a collaboration that comes behind this because they know what they do. They do it very well.
Hmm.
And there are other instruments. For example, I was mentioning the separator membrane. The pyrometer is one of our instruments, the pyrometer 3G. Not a lot of people manufacture this instrument. So when somebody's working on separator membranes, they need to understand the capillary
Hmm.
flow, understand their through-pore network. That's something that we work very well in. So we have people who may have gotten in at an earlier stage, probably on some heavy industry type of things. Customers saying, "Do you know anybody who manufactures this?" This is where collaborations exist, and we're able to help around this. So we don't get too many in Canada, I would say, of people starting ground up anymore.
Right.
There's a little bit more of a pivot from one thing to the other, um,
And scale up.
and scale up
Scale
from
up's the
there.
big one. Yeah.
So you have we have manufacturers in Canada, for example. I'll make a little bit of an analogy
Oh,
to
you're
this one.
trying not to say names, NDAs, and things like that? Yeah,
NDAs
yeah,
and
got
stuff
it.
like this because it's a very competitive industry. IP is crucial. We talked about the slurries earlier, so I'd rather not run afoul of these, but
Right.
I think I can make a little bit of an analogy to this of like bluebirdies flying around, and I think people will
Oh,
know.
that's not obvious at all.
Not obvious at all, but they are here in Canada, and they're focusing on different bits of work because they're everywhere,
Hmm.
right? Uh, Everybody's looking to build the next gigafactory somewhere. And with us having a robust mining industry, the access to raw materials that are
Hmm.
necessary for battery growth
Yeah.
across industry, the supply chain is much easier. This is where mining is going to continue to contribute to our economy, but also grow and evolve into the next stage to meet our circular needs as a society
Right.
with batteries as well. So, um, So for some of these more established, again, they're doing some of the fine tuning, they're qualifying their incoming materials. It starts there. They fix one problem or issue or fine tune, however you wish to caption it, and then you move to the next side. And because we have instruments that fit at every stage,
Mm,
we're able to meet that need. And because we share that connection to the scientific community. So I'm in Vancouver this week for the Canadian Chemistry Conference, and somebody remarked to me at another booth, they're like, "How do you know everybody? Like, who's that guy? Who's that guy?" Like,
mhm,
and they're expecting me to answer. So this is our strength at Anton Par.
mm.
So our team is spread out throughout the country. We're always speaking to people at research centers, universities, and they have us back because we are contributing to their work, and it's
Right.
always a symbiotic relationship because we're always trying to learn. The more we learn, every year we reinvest 20% of our turnover back into R&D.
That's
And that helps us
crazy.
grow our instruments and grow what customers, what end users, researchers need at the end of the day. So as they know, as that collaboration starts to grow, from starting from the research centers and the universities and pivots out into industry, uh, it's about helping drive the innovation as a whole.
And but you said that that's sort of woven into the industry, you would say,
Yeah.
that sort of collaborative approach?
Yes. Um, One of my favorites is, so we talked about this before, at PDAC. I'm a major proponent of hydrogen. I see hydrogen as taking us even farther into the future. Not to disparage anything we've talked about with batteries here,
Hmm.
but I'm a large proponent of hydrogen. And the hydrogen fuel cell community in Canada is quite small. So there is a company in Ontario called Hydrogenics. They were purchased a couple of years ago by Cummins. Cummins is the world leader in diesel engines.
Hmm.
Even as they're pivoting now to move from diesel engines to hydrogen power.
Yeah, I think they've got an engine coming out in a truck. Again, not brought to you by Cummins, but I think they've got a hydrogen,
Yep,
amazing engine coming out
yep,
for trucks. Yeah.
and an internal combustion engine,
Hmm.
with hydrogen. So Hydrogenics, Cummins, they're working with their electrolyzers. So with the collaboration, I was again meeting with someone at UBC a couple of weeks ago, and they're saying, "What? How do you see electrolyzers evolving in industry?" And I said, all you have to do is look at Cummins and where they're taking this into planes, trains, and automobiles.
Hmm.
Um, but they've been so focused on their research with PEMs, which means a proton exchange membrane, and they were kind of outside of the commercialization behind it.
Mm.
But to see that success, it kind of championed what they wanted to do, and they could see that, you know, I love research, I love science. I'm not going to stop here. We're actually moving somewhere forward with hydrogen.
And do you think is that I'm sure Anton Par will be quite involved with those all that testing and everything like that.
Indeed,
Is that the 20-year outlook? Do you think that will like are we going to see those vehicles driving around more?
I think so. I think there is a space where batteries are going to be a better solution than hydrogen, and there's going to be space where hydrogen is going to be a better solution than
What
batteries.
would be an example of one to the other?
Think about there's a lovely company here in Vancouver as well. I'll beat you to the punch this time. We're not sponsored by Ballard, but Ballard down here, they're focusing on hydrogen for ships, and you could think
Mm,
about how much transport is being done. I mean, you
mm,
walk around the seawall, you can see the boats coming in and out of Vancouver, right? That's good for the long range transport they're able to do with ships, cargo, etc. Hydrogen, great solution, right? But my wife, when she decides that it's time to run out to H Mart to get ingredients to make our kimchi, the batteries perfectly feasible around this.
and I just ask a simple question because I really am not uh, I'm trying to learn it, but I'm
Mm.
behind. So why one works better than the other in those two scenarios?
Difficult question, without painting myself into a corner around this, but I would think more in terms of the efficiency and the cost. At the moment, hydrogen is very expensive to produce.
Hmm.
So if you look at hydrogen, you see green hydrogen, pink hydrogen, etc. All these scales of hydrogen are related to how it's produced. So electrolysis is the main process of producing hydrogen, and you think about the you don't create energy, right? This is something we know from basic physics. You don't create energy. All you do is you move it from one form to the other. So there has to be an input energy. So
Mm.
where is this input energy coming from? Is it to create the hydrogen? So this is why the natural gas hydrogen that we have in Alberta is considered pink hydrogen because it's coming from fossil fuels
Mm.
versus something else that may be coming from another green source of energy, windmill, what have you, to impact the sustainability between the hydrogen production. So right now, hydrogen is expensive to produce versus a battery.
In effect, it needs to be a big generator of essentially revenue to be able to invest, make it worth investing in that. Or you're not going to go buy a $250,000 car.
Exactly.
Yeah, yeah,
Exactly. So as technology improves and research continues, those costs are going to come down, and then eventually, um, again, something simple. You're not going to be using hydrogen to power my Xbox controller,
right.
right? Maybe I'm charging it where it's somewhere else from solar or something else, but that little battery will always be a battery.
Just to tie it off with going back to the cars,
Hmm.
I remember someone was explaining solar to me that a solar panel, you can make these little improvements, but it can only each, I think, cell it's called. I can't remember. You probably know the technical term, but
Yep.
each cell can only collect so much energy from the sun.
Correct.
And is can batteries can the same weight of an electric car
Hmm.
one day take us to 1,000 kilometers, or is there only so much? Can they improve that much in their energy efficiency that they can go that much longer, or are we at a point now of its incremental improvements?
Difficult question for me to answer. Primarily because I'm not that focused on the research side.
Just give your opinion.
My honest opinion behind that is that's why I think the technology exists with hydrogen.
Mm.
And if we're looking towards batteries for very long term transport, hydrogen is more efficient behind that. Now, this is purely my perspective.
Right. Yeah.
Don't
Yeah.
tie this to Anton Paar.
Right. Of course. So, but going back now to Anton Par,
Hmm.
with your end goal to
Hmm.
tie that all together,
Hmm.
when you're going in and testing, you're bringing all these services to a company,
Hmm.
to a manufacturer.
Hmm.
You're trying to essentially get these improvements along that whole process
Yes.
is to get at the end result a battery that they need to do. If it's in a little Prius, it needs to go 40K.
Yep.
But if it's in one of these major electric manufacturers, they're trying to go, however, I don't even know how many they're going now. So it's quite far now.
Yep.
So that's that process that you're getting involved in and trying to get that efficiency up to that percentages at a time.
Exactly. Our the end users of our instruments, they have benchmarks that they want to hit in terms of improving their product, in terms of providing something larger into society. And you talked about the incremental growth. This is where the instrumentation and the testing that is possible with Anton Par instruments will bring that into focus.
So I'm going to tie it off with this
Hmm.
question: is you talked about going back into R&D
Mm.
as the industry evolved.
Hmm.
A an instrument from 10 years ago, how much does that evolve? Are you adding new instruments or are these instruments getting improved upon? I'm sure it's a bit of both, but I'm just curious as the industry scales up, is it the size of the instrument? Is it how they all work together?
Hmm.
What is sort of the big R&D push within this battery testing space?
It's a little bit of each one of those points. So as technology evolves, I mentioned an instrument earlier called the Nova. So when we had an early iteration of the Nova 1200s, we didn't have a touch screen on there. But now with the new Nova 600, Nova 800, there's a fully functional test touchscreen on there where you can look at data
Mm,
as your analysis is being performed. You can go back and look and see your data quality, and then decide where you have to do more on the data reduction on your computer, etc.
right.
and it's also a little bit more compact than one of the earlier Novas. Technology has evolved, so it's a lot more automated, so you can
Mm,
move forward with that. Another instrument we have is the UltraPick, which is used for solid density. So instead of having to do a manual adjustment on your gas flow rate, it's all automated now, to the point where there's something called elutriation, where when you introduce the gas into the system, it gets picked up and then it gets taken to your valves,
mm,
kills the instrument. We have something called powder protect mode, where even when you're working with a very, very fine powder, elutriation is gone. And then the instruments get fine tuned over time. One of my favorite instruments is something called the Surpass 3. We use this to study the surface charge of solid materials. So anytime you have a liquid coming into contact with a solid, there's an interfacial property, and we need to understand that surface charge or that surface zeta potential to know how they're going to interact over time. So we have individual cells. We have one to measure contact lenses. We have one to measure hollow fiber membranes. So core samples. This was one where I was very proud of because it was part of a project we were working on at University of Calgary
mm,
to take core samples and measure the surface zeta potential because you wanted to know about the fluids that are being pumped into the well
mm.
to more easily um, extract oil from reservoirs. So
Yeah.
enhance oil recovery, as it were. So a little bit of both. So innovation to as projects continue to grow, as needs continue to
Yeah.
evolve over time, and then also adapt to the new technologies that come out to enhance the functionality of the instrument and new instruments all the same.
Yeah, well, and I guess that is that communication between instruments feeding data back and stuff. I guess that's a major push across basically all industry now. So I'm sure
Yeah.
it's very similar to you.
Data integrity is crucial across every industry, from GMP um, models that need to be followed to ISO certifications, etc. One of our software platforms is something called AP Connect. So instead of being like old school Atri, where you have a notebook and you're writing down everything all the time, you maintain your data integrity by everything getting pushed to a computer or to a
Right.
LIMS system.
Yeah, I used to be into notebooks until I figured everything's on a cloud and I can just type in. I just need to remember 3 words of a sentence I wrote and
Uh,
bam, I found it again. Oh, just the best. The
I
best.
color myself in the Anton Paar in our innovation a lot. I think I need to adopt a little bit more of this future forward thinking
Yeah.
myself.
Yeah, one day I would love a window into that R&D department because that must just be a fascinating, I mean, unbelievable what you're doing in there. So
Thank you.
thank you very much for coming back on the show. It is, and I say this a lot on the show, but it's never becomes any less true. Is when people are doing multiple episodes, it is so much better for this format because you get to actually focus in on certain areas. And we've had some people try to pack in. I was just actually having a discussion with a large organization,
Okay.
and I was trying to separate them. I'm not just trying to sell you to do a whole bunch of episodes with us. It really is just going to be hard to unpack it all. And Anton Parr has done an amazing job of working with us to just focus in on these topics and actually educate the audience. It's just amazing. So I really do appreciate your time to do
Thank
it.
you so much for having us on. I do greatly appreciate our conversations. It's always collaborative. You've given me quite a bit to think about, especially how I think about the evolving needs for batteries, especially in transportation. Not something I thought about. I gave you a bit of my opinion there, but something I'd like to revisit myself and understand where we're going from there. And
Well, I'll try to find out something that I can actually learn, then I can be the one educating you. That'd be a great
well,
feeling to a
I
physicist.
mean, the last time last time I asked you, a question, I was like, no, we're staying away from that this time. If
Oh,
you'll,
trying to interview me on my
yeah,
own show.
on
Yeah,
your own
that's not
show.
going to happen.
Well, I think Rory was supposed to be here. One thing, I'll probably put it on film here. I'm not sure it's going to age well. Is hi Rory, go 49ers.
I yeah, he's right into football. I can't. It's too stressful watching that. I get really tired of cheering for teams, and my teams never ever win. Yeah, thank you very much. And I wanted to say a quick thank you to the audience. I mean, we've just scaled up and done more and more episodes. You keep supporting us. Want to thank you for watching us, suggesting guests, connecting with us people. It's connecting us with people. It's all very appreciated. Thank you, and we will see you on the next episode of the Building Energy series.